Welcome to the Power of Experimenting Science Activities for Your Program. My name is Grace Eilers. I will be the facilitator for this evening. And there are many family childcare programs that are highlighted throughout the event tonight through photos. We're also going to hear from two main contributors through video interview, and that being Marilee Ihani, owner of Shishu Family Childcare in Appleton, and Mary Laufenberg, owner of My Second Home Family Childcare in Waunakee. And again, we also want to hear from you. So a large portion of our event tonight, it's going to be dedicated to idea sharing and discussion. And this is because we know that many of you are coming here today already doing a lot of scientific learning in your program. So let's introduce this 2-hour event that you have chosen to attend or watch after the fact. And it's all about experimentation tonight. And this is because science, when we think about science in early childhood, that's a really big topic. And there are so many directions that you can go in when you're thinking about science curriculum. So tonight we're going to focus on experimentation. So that means how can you, as an educator, support experimentation in your program through your interactions, the materials you have in your space, and the activities that you offer children. And we're going to go through 3 different types of experimentation today, those being experimenting with nature, experimenting with transformation, and experimenting with construction. For each of these categories, we're going to offer material ideas for child-directed play, again, some of those adult-led activities, and then we're going to hear from you about what you have or are doing in your program to support some of these types of experiments. And I selected these 3 categories purposefully to focus on today because these are all things that you are already doing throughout your day. So we're going to talk about things that maybe you have done something similar, but we're going to add a scientific learning component to it. So we're going to begin before we get into each of those 3 categories, by outlining scientific learning in early childhood. What does this look like? And where are children at cognitively to be able to process different scientific concepts that we might offer the opportunity to learn about? We will be looking at experimentation through the lens of the scientific method, the foundation of all scientific exploration and innovation, and how this natural process develops for children over time. So the scientific method, that's a process that we all use every day to solve our problems or make decisions, and it is something that matures over time for children. So you can see that depicted here on the slide. We make an observation. Maybe it's a problem to be solved. Oh no, there's one of the ingredients that I was going to use for dinner has spoiled. The question I may come up with when thinking through this process is, okay, well, what do I have on hand that I can make that I already have in the house? And then we're going to get into the hypothesis phase on our cycle. Okay, well, I have these ingredients right now. Maybe I could make this instead. And then the experimentation phase. The experiment phase, that comes when, all right, I'm going to make my alternate meal that was different from what I had originally planned. And then I can conclude, okay, whether was this a good alternative or not. And this cyclical process is the foundation, like I said, of all scientific innovation and creativity in our society. And this thinking process begins when we're very young. So for an infant and children under 18 months old, like the middle child in the image here, they are bouncing back and forth between observing and experimenting. You see this all day long. That cause and effect of, I notice this, I do this, and then I notice this happens. They are testing this process out in that way. For toddlers, maybe the one on the right-hand side of the image here, who understand and are beginning to become aware of their bodies, they begin to realize and test out, okay, I observe the bubbles in the sensory bin. I'm I, I will hit those bubbles with my hand, and then so I'm going to experiment with that, and then I'm going to conclude that, oh, it makes a fun splashing noise. And then as children grow into preschoolers and school agers, they then have the language to organize their thoughts and their wonderings about the world into questions and then start planning and hypothesizing. And there are ways that you can help nurture this as an educator. So here we have some examples of, we're going to have some examples of open-ended questions to support children's critical thinking through the scientific method. So for observation, any form of what do you notice? What do you see? For the inquiry questioning phase of the scientific method, why or how does this happen? For the planning and predicting phase, that hypothesis phase, how could we find out? And what will happen? Then we encourage children to test out their plan and experiment, try something out. And then you may simply ask, what happened? And I encourage you to notice that when we talk about experimentation as we go through and we have activities that you can try, we're going to use this framework to think about how to support critical thinking skills in a way that is innovative. And it's not simply just giving children answers or facts about the world. It's about turning the question back on them. And because so much of this comes up for children when solving problems, we are going to hear from Mary about how she supports children through problem solving. And you are going to see how her response is reflective of some of the open-ended questions that we just talked about.
What I do when my kids have problems, we don't call them problems, we call them dilemmas. And so what we do is we have to find a solution to our dilemma. So what we do, I ask them, okay, so here's our dilemma. What do we have to do, or you have to do, to figure out how to solve it? So that comes as much as we are working with the magnet tiles and somebody wants to knock over the tower or whatever you're building. Okay, so how do we solve that problem? What can we do? What can you do to solve that dilemma? So a lot of times we talk through it. We say, well, we could ask them, they want to play with us. If it's a younger one, we can give them their own magnet tiles. We can go and ask Mary. Sometimes we don't usually ask Mary because Mary tries to get them to work it out amongst the group, because that's really a life skill that is important for everybody. And so I started very young.
So you could see and hear Mary talk about how, I'll go back to our cycle. She is engaged with the children through that problem solving process, through that critical thinking of, I have a problem, I'm making an observation, and it actually is bothering me. How can you solve it? Let's brainstorm together, test out, see if it works, and then decide, all right, did your tower stay up for as long as you wanted it to because you moved to a different area? Great. That worked. And then the cycle begins again later on that day, maybe 5 minutes later. So now we want to hear from those in the room. And I do have a visual timer up on our screen just because I want to make sure we have lots of different ideas to get through tonight and different categories that we're going to be learning about. And I want to make sure that we have enough time for all of it. So I will start the visual timer and it'll let us know when we're out of time for this question. But this is just an opener to get you thinking about what's already happening in your program, what's happened recently, scientific, what are some scientific learning that you've seen and witnessed recently in your program? And again, so you can use the chat or you can unmute to share. And like I said, I have that timer that I will start right now. Patricia says lots of bugs, including monarch caterpillars that we observe and troubleshoot when they are bothering us.
I saw something neat in the program this week that I could share. They had a wading pool and some of those magnetic water balloon, or do you know what I'm talking about? Water balls that like magnetize, and then pom-poms. And the kids were like figuring out how many pom-poms could fit inside and still magnetic close. And then what would happen if you'd throw them and they'd like pop open and all the pom-poms and everywhere. That's pretty cool to watch.
Water play with different tools, bubbles, watercolors. Jesse says color sand for art. Mary says we have been using our water table outside because it has been hot. Yes, it has been. The younger children dumping the water on the ground. The older kids noticed that the water was disappearing. We are going to continue on. Thank you so much for sharing your thoughts. And like I said, there'll be other opportunities for you to share more about what you do for those specific categories that we are going to talk about today. So we're going to dive a little deeper into the thought process occurring inside a young child's brain. The young children, they are limited to processing ideas through their perceptual processing systems. So what can they hear, see, smell, taste, and feel? And children cannot think abstractly about concepts that are not tied to real world examples. So concrete thinking is what children experience with their five senses. Whereas abstract thinking, those are concepts, theories, meanings behind experiences. And humans do not acquire the ability for abstract thinking until we reach adolescence. So for an example here, you might be wondering why there is a tree on the slide. Here is our example. An example of concrete thinking would be, this is a tree. It has green leaves and brown bark. It grows from a tiny seed and has roots that keep it in place. Children can experience all of these components with their five senses. For an example of abstract thinking, this is a tree. It represents strength and resilience through adversity as a strong foundations of roots hold it upright and strengthen it deep within the ground, even through the strongest of storms. That is not something that a child would be able to think about in a way until they reach adolescence. And we're going to see a couple examples of what this looks like for children right now through videos. In this example, it starts a little cut off. The young boy here has to imagine, they're asking the child to imagine a world in which there's a rule. If you hit a glass with a feather, it will break. And we'll see what his response is.
With a hammer, the glass will break.
I knew that.
And then this one says, Dawn hit a glass with a hammer.
I knew that too.
So what happened to the glass?
It broke.
It broke. Why did it break?
Because the hammer's hard.
If you hit a glass with a feather, the glass will break.
No, it won't.
And this is the second rule. Dawn hit a glass with a feather. What happened to the glass?
Nothing.
Nothing happened? Why didn't anything happen?
Because the feather's soft.
First one says, if you hit a glass with a feather, the glass will break.
Okay.
And the second one, Dawn hit a glass with a feather. What happened to the glass?
It broke.
And why did it break?
Because the rule says if you hit a glass with a feather, it'll break. So if you hit a glass with a feather, it broke.
So you could see in that video, the younger child fails to, they make a mistake. They fail to say that the feather will break the glass because he is thinking concretely and in the here and now in this world, where the adolescent can imagine a hypothetical world in which it would be true, there would be a rule, and then apply that rule to the current situation. So a great example of concrete versus abstract thinking through this video. That we have another example now. We'll see a younger child make let's call it a liquid conversion mistake.
So I got some rocket fuel right here, and I'm going to pour the rocket fuel into a container for you. And I'm going to pour some in a container for me. Okay, is that close now?
Yes.
Okay, now it's the same. So I'm going to ask you again. Here we go. Do you have more rocket fuel? Do I have more rocket fuel? Or are they the same amount?
They're the same amount.
Great. You both have the same amount of rocket fuel. Now, before we put them in our rockets so we can go on our shopping trip, I have to take my rocket fuel and I'm going to put it into this container. Watch me do this. I'm going to put all the rocket fuel in here. Every last drop. Okay. Now, do you have more rocket fuel? Do I have more rocket fuel, or are they the same?
I have more.
You have more? Why do you have more rocket fuel?
Because that's a big cup, and a big cup can be. A big cup is shorter than a tall cup.
Okay. So if I put the rocket fuel in your rocket car, and I put this rocket fuel in my rocket car, whose rocket car is going to go further, yours or mine?
Mine.
I want you to tell me when we have the same amount of rocket fuel. I want to make them even. Are they even
There.
now? There, okay. All right, so now, do I have more rocket fuel? Do you have more rocket fuel, or are they the same?
They're the same.
Great. Okay, now, well, I need to take my rocket fuel and put it into another container. I need a bigger container. So I'm going to pour it in here. Okay? Now, is there more rocket fuel in your container? Is there more in my container, or are they the same?
Same.
So as you could see, the younger child in this scenario, the first child, has not yet learned about volume, this concept of volume. So she's basing her understanding of amount by the height of the water line in the container. And she's not considering the impact of the container itself. And this is something that just a few years later, the older child can now take into account. So now we're going to hear from Marilee Hani as she answers this question. How do you encourage children to use and refine their perceptual skills? Again, how do you encourage children to pay attention to their auditory, their tactile, and their visual information that they're getting from the world around them?
I keep them in the real world. We don't use screens or electronic toys. When I opened over a decade ago, I removed the batteries out of all the toys that I was getting to start up, and I felt that the batteries robbed them of the opportunity to exercise their imaginations. And I had like a little kid in the beginning who was like, my fire truck's not working. And I was like, what do you mean? He's like, it doesn't make a noise. What can we do? And I was like, well, you can make the noise. You can say we're and he was like, oh, okay. And then he went off and was like making a little siren sound. And I was like, one of those moments where you're like, this child like hadn't figured out like I can do that because it always had been done for him. And even with like younger children, with when a baby hits a rattle, that's a direct response. Their action caused something. When they hit a toy and it plays music for 3 minutes, that kind of lost that direct relationship. It becomes a background noise. It can be overstimulating when it's got all these other things going on. And so I like to try to keep it more simple so that they're actually experiencing everything. Um, we use technology if it's in a way to further their learning and with something that they can't do themselves. And then it's great. But I try to keep more real materials. If we're doing music and there's a song on YouTube we want to listen to, we listen to it. We just pop a different thing on the window on the screen so they can't see the screen, and then they love dancing along and doing the whole song, but they aren't being distracted to try to watch something instead. And so just keeping them all aware and just through those interactions with each other, they're constantly exercising this.
So for all of those reasons that we talked about so far, that we heard from Marilee, it is critical that you are mindful of, as Marilee puts it, keeping children in the real world. So that is why we're going to focus on hands-on experimentation today. This is how children learn about scientific concepts like gravity and life cycles because they can see, feel, smell, taste, or touch it. Marilee also talks about screen use in particular. And although screen media can definitely be a tool, it's something that is only valuable for children over 2. So research is telling us that children under 2, they do not learn from viewing a screen. Their brains are physically physically unable to comprehend and learn effectively from even educational media. So for children 2 and older, you may choose to use screen media to supplement maybe a learning moment. And we have an example here on the slide. On the left hand, here in that left image, I went on a nature walk with Learning for Life, and Michelle pointed out to the children, look, there is some skunk cabbage that was growing right off of the boardwalk. And if you don't know, skunk cabbage, they have these really, really neat, big, beautiful flowers that bloom. They're smelly, but they bloom in the spring and they look really cool. And the ones we saw on our hike, they had not bloomed yet. So Michelle pulls out her phone, looks up an image similar to the one that I just popped up on the slide here, and showed children the photo of the flower. 30 seconds of screen time to help children connect with the world around them and engage with the world around them. Say, this is what that plant is going to turn into and look like in a couple weeks. All right. We are now going to get into our first category for the evening, experimenting with nature. And that was already a big theme that came up when I asked you what scientific learning has recently been happening in your program. Many of you thought about and spoke about how you play with nature. Here are some of the learning possibilities that may come from nature experimentation. So this is not all-inclusive by any means. It's just something to get you thinking about what are some of the ways that what are some of the concepts that children are learning about when they engage in nature play. And if you have more ideas, which I'm sure you do, that you would like to share, please do so in the chat. So first, this is a particular value of mine, is the importance of learning about permanency. Nature's messy. Nature is breakable. It's strong, but it's also very fragile. And children learn that their actions sometimes have permanent consequences when they experiment with nature. So they learn when I take a stick and I break it in half, there is no returning that stick to its original form. You might say, oh, well, you could tape it. That's true, you could. It is still not the same. Children also learn about earth cycles like weather and seasons. And again, like some of you pointed out, how water reaches the earth and then it disappears into the earth. Here we have a simple rain gauge for children to visibly see the quantity of rainfall. Children learn about food chains through nature experimentation and also ecological relationships as well when they see plants growing from sunlight and then insects and mammals that come and eat those plants. And then they also learn about life cycles as they can witness with their own eyes real growth and change over relatively small periods of time. So those are just some of the learning possibilities of nature experimentation that'll come up later when we talk about some of the activity ideas and the material ideas that we get to. But first, we're going to hear from Marilee about how she incorporates nature and natural materials in her program.
I start by creating an environment. So the color palette of my space, I have like light green walls, and there's tan, white, gray. Just keep it very simple and clean, calm colors. There's not like bright, bold primary colors. It's keep it more in the natural palette. Um, so that's the first choice I make. The next one I do is considering what materials I use. So my shelves will all be wood and like kind of just a blonde natural colored wood. Um, and that includes their tables. Their toy kitchen is made out of wood. And we use woven baskets that just give them that texture. And so I start with that. And so even though with childcare, obviously a lot of the toys will be made of plastic, but to just start by creating the overall environment inside to reflect that. And I feel with just those starting choices, it creates a calm, fresh environment to start with. I personally prefer to keep like kind of my inside and outside environments as separate because I feel like they both have value, and I want the kids to be able to embrace the experiences in each environment that they each have to offer. Um, that said, I do have natural elements indoors, like we have seashells and different unique stones and things like this. But these are things that then they don't have that outside because that way they have it a little more fresh when they're playing with it and one versus the other. We also have little resin insects that are like frozen that they can, look at and play with and see. So we incorporate those kind of elements. And we also have these little tree blocks that are they're not the tree cookies, but they're like these little blocks, maybe this big, that are kind of out of branches and that they can build with as well. Another thing I find is that part of natural materials is also just having realistic materials. Like it doesn't have to be pure nature, but just bringing the real life to them through that. So all their toy foods are life-size, realistic toy foods that I can find. Sometimes it's hard getting those, but and their dolls are almost all life size, anatomically correct, real clothes, so that they can actually practice with real things. And I think that that's an important part is that nature doesn't always, like natural doesn't always mean direct nature. And I recently got these little cushions for them that are tree stumps that are like soft little pillows that they would stack them, and they're cutting them down, they sit on them, and they're like considered 3D printed some sort of fabric that it really is a nice way to kind of bring that element into it too.
All right, we're going to expand on what Marilee already talked about with some material ideas for nature experimentation in particular. So this is going to help promote nature experimentation that results from, say, child-directed play. So these are materials that will help children organically experiment with nature. I have a few photo examples on the slide, but please refer to the handout for this event for a full list of ideas. And then if you have more ideas, save those. We're going to talk, and I'm going to collect some of those and make sure that they are added in a follow-up email. So things like sticks, leaves, soil, water, rocks, sand, pots and pans, as you can see here in one of the images. Things like magnifying glasses and binoculars, insect nets, jars, or like bug catchers. And then writing materials. It's a really big component of supporting scientific learning and literacy is let me give you a notebook and some markers for you to write down your notes about your observations that you are making in the natural environment. And Stephanie, I don't have the chat pulled up. If you haven't already, could you please send the link to the online version of the handout for folks that weren't able to print it out beforehand or have it open, just so they can have access to it? Because our slides are very visual in nature, and if you would like more detailed information, that is going to be included in the handout.
Yep, should be up there.
Okay, great, thank you. We also, here you can see more different types of baking pans and pots, shovels, nursery pots, just the plastic ones, save those, and various seeds for planting, all can be offered to children for nature experimentation. So plants, you'll notice there's one mention of native and or edible plants in the material list on the handout. And we're going to call out the importance of having living creatures in your outdoor environment and your indoor environment, I would argue, but particularly your outdoor environment. And this is this is an example. This is Sarah's program, Silly Sprouts, an example of how you can plant native perennials. I think there's a mix of annuals, fruits and vegetables, and native perennials in there. And how those plants, those are going to help attract the additional living creatures that are necessary for children to learn about some of the nature concepts that we covered earlier. So things like when you catch a butterfly, and if you rip a butterfly's wing, it cannot be repaired, and you have harmed that creature. When you take an earthworm and rip it apart, you cannot put that back together. When you squish an ant, there is no bringing that ant back to life. When you rip a leaf off a plant, you cannot then go and reattach it. All of these moments through nature play and experimenting with nature are inherently teaching children that their actions have consequences, real consequences. And then there's also the ecological relationship component that is activated when children engage with living creatures. And it is important to know that humans, we only come into this world with two innate fears: the fear of falling and the fear of loud noises. We do have a sensitivity, we have like a sensitive detection system for snakes, but fear of snakes and anything else in the natural world is a socially learned fear. So keep this in mind as you, as the adult, as the bigger, stronger, and wiser and kind adult in the space, how you model engagement with living creatures in the environment and what messages that might be sending to children. All right, we're going to hear again from Marilee. And Marilee is going to talk about what outdoor play looks like in her program. In the first video, she talked a lot about how she brings natural materials and nature indoors. And now she's going to talk about what outdoor play looks like.
Outdoors that's our free play. That's really where, like, when it's nice out, we'll do our activities outside too. But for the most part, that's where they're free to just do anything they want, and they know what the expectation is, and they have a lot of fun. As far as like playing with sticks goes, we have just like two rules basically. And for stick safety, that is that it can't be longer than your arm. So they all know to hold out their arm, hold up a stick. If they're trying to say, oh, someone's stick is too long, they'll hold out their arm and I'm like, okay, we'll break off this 3 inches, but I felt that was a reasonable length that they can use it for all different things, but it's not out of their control. They're aware of what space that stick is in versus if they try to take one that's like twice as tall as them, they don't realize that they're leaning it too far back and hitting someone. But they also all will work together and pull a big branch across the yard that fallen down in the storm. And so they still work together for things like that. But if they want to run around with it, they know that they need to measure it. And they're not allowed to hit each other with sticks. Another section of the yard we have is the rock garden, and that's where we have kind of river rocks that they can dig in. That's where they like to look for bugs. We have big metal construction trucks, so we get those out if it's dry out and not rainy. And so they always love to just play in the rock garden with the trucks and digging and building. That's their world. They love to, spend as much time outside as we can. We will go for walks. And then for that, we have an elementary school right half a block away. So in the summertime, we go over there to play sometimes a little bit. It's a little harder for them the rest of the year because they're like, can we go to the playground? It's like, no, the big kids might be using that. So we can't use that right now, but they still enjoy like walking. They have like a board. They know that it's fun. They enjoy walking around the school. There's a little take a book, leave a book. So we pause there. They all take out a book and are looking at it just on the front lawn, and then they put it back. And another time we were going for a walk, and anytime we were walking in the shadows of the trees, we had been talking about Norway recently, that they have a lot of tunnels, and the kids decided every shadow of a tree was a tunnel. And sometimes it takes me a minute to connect, like, why are they talking about tunnels? It's like, oh, 2 days ago we talked about Norway having tunnels. And so we come up with lots of fun games while we're going for walks as well.
Now we are going to cover 4 activities that you could do with children to help target some of those learning possibilities that we covered earlier. The most basic of all of them is to simply grow plants from seeds. There's so many ways to do this, and encourage children to observe the changing growth that happens right in front of their eyes. So one way to take this a step further when thinking about scientific learning for the preschool age children and older would be, okay, we're going to place one plant in the shade and one plant in the sun. And you don't even need to tell children that you're doing this. And you might just wonder over time what may be happening as one plant thrives and the other one grows a lot slower or doesn't grow at all. Children are learning about life cycles, and this also includes the fact that the plants will die, or some will die, some will go dormant at the end of the season. So they're also learning about the life cycle in its entirety through nurturing and growing plants in our temperate climate. This is one that I heard Walker talk about earlier, deconstructing or just gathering different types of materials. Deconstructing natural objects is another way to experiment with nature. So using tools and resources that you already have in your program, or things like maybe you want to go out to the thrift store and get a mortar and pestle to have children crush and press different types of natural materials, and inviting them to break apart, to notice what happens when I squish the leaf, what happens to the texture, what do you smell when you take you could take like whole spices like cloves, have children break it up, or even flowers. And that sensory component is really strong with nature play, particularly for this activity, because again, there's so many visual, auditory, olfactory, tactile experiences and changes that occur when we take nature and break it apart. This is a fun one. I'm curious if any of you have ever made plantable paper with children, or just in general for your own fun. For this, you want to gather up all of your paper scraps that you have on hand from all the cutting, all of the art projects that ended up in the recycling bin, place them in a blender, pour in water, warm water, until you submerge all of the paper that's in there. And then you blend it up. You blend it up until you get a pulp consistency. And then when you open up the top, you're going to see that there is some water standing at the top. You can just discard that and scoop out some of the pulp for children onto felt sheets. You can see that here on the slide in green. And invite children to press, press, press the mixture into like this flat sheet so that they're squeezing all the water out of it. And then you can just get a mixture of seeds from the store or gather seeds from your environment and press them into the top of your paper. And then you're going to set it aside and you're going to let it dry completely on the felt sheet. After it's dry, you're going to take it off. And this is when you can have fun cutting it into whatever shape the child may desire. So lots and lots of developmental components being activated here when you make plantable paper. Oh, and then the best part is then you can plant it in soil and see if something grows. So another experiment is exploring pigments through leaves. So for this experiment, go ahead and collect a variety of colored leaves, boil them for 5 minutes, and then go ahead, this is something that you as an educator are going to be responsible for, obviously. Then you're going to go and submerge each leaf. And this, you can just do this with green leaves. I know it's summer right now. We don't have our beautiful autumn colors yet. We're not ready for it yet, but we will soon. And you can submerge them in a container. It doesn't have to be a wonderful science container like you see on the side here. Container full of rubbing alcohol. And you just let it sit for about an hour. Then you come back and you observe what happened. What the rubbing alcohol does is it extracts, it pulls out the chlorophyll from the leaves. And it's like magic. All right, I have to plug if you are participating in Satellite, here are some curriculum units that would be relevant to nature experimentation. So we have the science exploration unit right there in the name. You get a bug catcher, you get lots of different rocks and minerals to explore, you get magnets and different types of magnifying glasses that you might not see very often or might not have access to. I'm not sure if I said tweezers yet, but those are also included in there. And then another example of something that you could loan out if you are participating in Satellite is our bug unit. Very connected with especially the season that we are in right now. So now this is the time we want to hear from you. I know many of you had already talked about some of the nature experimentation that is happening in your program. This would be a time for you to ask questions or if you have specific questions for other educators in the group, or just share what you are doing in your program. Again, this is a chance for us to gather ideas from those in the room. Mary says, last year we planted rainbow carrot seeds in our garden. I let the children water the garden. Did you get carrots? I am very unsuccessful with anything I try to grow to eventually be eaten. Anything outdoors, I'm really good at indoor gardening. No, you didn't get carrots. That's okay. It's all about the process. Tracy does outside scavenger hunts. Ooh, what do you look for? What are you searching for, scavenging for? Stephanie says letting children cut up or rip up flowers in the potion making station. They also love doing the same with pine cones. So now let's talk transformation. So this is experimentation with responses or processes that happen when we do things like cook, when we bake, when we play with temperature, when we combine materials together. This is my like very broad category that encompasses all of those things. And children learn about concepts like chemical reactions when they can experiment with things like baking ingredients. They also learn about temperature, how temperature impacts matter when they see something freeze and thaw. They also learn about measurements and states of matter when they, let's say, mix ingredients together and now they've transformed banana bread dough, which is really a liquid-based colloid, into now a solid. And then they also learn about time and its impact on changes when they observe water, say, evaporating or waiting for something to cook or bake or freeze. All of these different components here are learning possibilities of transformation experiments. Now, the material idea list was a lot harder to come up with for this one because a lot of the experiments that we'll talk about are things that I am unsure how comfortable folks are with just having out for child-directed play as a whole, just out in your environment. So you'll see if you look at our handouts for the list of material ideas to promote that child-led experimentation during child-led play, thinking about mixable materials that you feel comfortable with putting out in your environment. So these are things that will combine or maybe dissolve, and then mixing tools, mixing materials. So tools that support children in creating safe chemical or let's say state reactions on their own. So things like spoons, funnels, bowls, whisks, all of those great things. And if you have other ideas, please put those in the chat for others to see. Marilee is very passionate about baking, and she was the inspiration for including this category in tonight's event. So we're going to hear how she tells us, as she tells us about baking with children in her program.
It can be as simple or as complicated as you want it to be. Um, it can be teaching the kids how to spread peanut butter on a slice of bread. That is a fine motor challenge and a life skill for them. So it's not that everything has to be complicated. You can do it in any kind of space. The kids absolutely love helping in the kitchen. I have different theme days. Once a week, it is cooking day, as the kids call it, and they're very excited. They're doesn't matter what we're making, whatever it is, they are always enthusiastic to help out. Though depending on what it is, they may be more or less enthusiastic about eating it, but they are very excited at the beginning. Um, they know exactly where to get all their supplies, wash their hands, come ready. Uh, I was actually on vacation for 2 weeks, and when I came back and I was like, okay, it's cooking day, and the kids ran ahead of me. They're like opening the cupboard, pulling out a stool that we have a little folding stool. They're running in the other room, grabbing another stool. And I was like, oh, these guys like have it down. And next thing you know, they're all like lined up and they're ready to go. So they are very set on it. With that, everyone gets a turn to add an ingredient, and it's more fun the more things you can add. So if a recipe is a tablespoon of something, 3 teaspoons are a tablespoon. So we use the smaller instrument, and then they can count as they're doing it and make sure that everybody gets a turn. Um, it's another what scoop you use. That's another opportunity to talk about like, oh, we're going to use the quarter. Oh, 2 quarters. We just added a half cup, and you're able to bring all that in a natural setting. The kids' favorite piece of equipment in the kitchen is the KitchenAid food processor mixer. It's an amazing machine, and they all circle around. They are very enthusiastic for it. I had a 3-year-old once that when his mom got one for Christmas for her, Like that, I think beat out any of the toys he received. He was so happy to see that at home he now had the KitchenAid mixer and they know just what to do with it. The kids are able to taste while they're cutting up things and they can smell the ingredients all along the way. So we'll, find a way that they can do that so they can see it as they're working with it and how it's transforming along the way. Um, they're super fussy eaters. They probably still won't necessarily want to touch it, but they've still been exposed to it, and now it's demystifying it. They're seeing what's being put in, and eventually they will get there to try and bite. But a lot of the other kids, like most of the other kids, are going to be excited to try it, that they made it, and they'll be like, "Yeah, this is so yummy. This is so good." They might still leave it on their plate, but they still have that excitement that I made this, so it is good. I just don't feel like eating it right now, and that's okay. For the types of things we use, I do not recommend buying the plastic kid knives because those things do not cut. They're just hard to use. Save your money on that. But one nice thing if we're cutting up something is we have like a crinkle cutter that they can just put their hands on top and push down. So we are able to talk about, oh, no hands underneath. We keep our hands on top. And then you don't have to worry about something being under it. Another tool that they love is the like Pampered Chef food chopper. So you just put it in it, put your thing on top, and they can hit it. And I usually try to use things like this where they are really using their own muscles to push and have fun with it. And they all want to turn, so they get that. With this, they're learning life skills. They're learning healthy eating. They're learning food and kitchen safety. Uh, I was really surprised when, for my own children, I went to their conference and their gym teacher was talking about how they had a health, gym is, physical and health education. And he was talking about teaching the third graders food groups. And I was like, pretty sure my 3-year-olds know that. So this is a great time to get it for them to understand that they all are able to, tell me which things are on their plate, where they come from. By the time they're in elementary school, food comes in a plastic package. That's what school provides. And this is where they can actually get real food and be able to make it. Obviously, in the kitchen, we always think about math and science. But what I've realized is that cooking is really about connecting to culture. And it's a great way that it's a community contributing. Everybody's helping. We're breaking bread together. The the kids one year, we over the course of the year we made bread from around the world or through the alphabet, and the kids learned what is bread. It is so much more than just a sliced loaf. They got to roll it out. They've seen all the different shapes, how it can be baked, it can be cooked on a pan, it can be all different things. And I think this is one of the things I love about cooking. And I make my own little challenges that this year we're going to do soups through the alphabet. This year it was one year it was breads. In the kitchen, it's just such a tactile experience. The kids are rolling, they're patting, they're filling, shaping, braiding, chopping, stirring, mashing, pouring, measuring, and also just taking turns and having that patience and waiting. And it's just one of their favorite things.
Now we're going to come up with, Marilee talked a lot about how she involves children in cooking and baking throughout the day, something that she already is doing, and all of you are doing as you prepare meals for young children. So now we're going to talk about some additional ways that you can incorporate things like experiments with transformation and reactions and processes that are more adult led. So this one, I guess this one's more of a balance. It's not as adult led because it is open-ended baking. And this one, this is Danita Dinger recommends this activity. And essentially, you offer children the opportunity to create their own dough to bake, simply just using flour, sugar, spices, salt, and water. And you may choose, okay, I'm going to add in some other ingredients like oil or softened butter if you're really adventurous, or different ways of combining materials together. So offering things like eyedroppers or mashers or whisks. And Danita she also, you can see she offers some cookie cutters too, and offers children the opportunity to play with measurement and balance too, and observe the consistency changes that take place when maybe you add too much or not enough of some ingredient. And all of these ingredients are obviously taste safe too, so I would absolutely recommend that you offer some combination of materials to your infants as well. Danita does bake what children make and then allow them to try it. I am unsure whether or not this is actually safe to do, so I'm going to let all of you be the judge of that. But simply, this one is just for the process of that tactile experience, witnessing different ingredients combining and creating something new. So another idea would be to experiment with things like freezing and melting. And a couple ideas here on the slide. One way would be to experiment with this would be to take 3 ice cubes, place them all on different surfaces. So one on tin foil, maybe one on white parchment paper, and then maybe one on black paper. And then leave them all out in the sun on a hot day. Could have done this today. Today would have been a great day to do this. And then just simply observe the difference that takes place over, some period of time. So maybe you set it out right at the start of your outdoor time and you go and check back in at the end. And again, there's no need to explain to children why one surface would cause it to melt faster. You can certainly do that if that is a value of yours and it's part of your philosophy. But the underlying purpose here is simply to engage children in critical thinking and just ask those open-ended questions. Well, what happened? I wonder why this one melted faster. And I know a lot of educators love to freeze materials in water. I think that, if my memory serves me correct, that was mentioned earlier when we were talking about recent scientific learning that was happening, where you freeze materials in water and then you invite children to help them escape with a syringe or an eyedropper and some warm water. All right, as promised, we are getting to our play with baking soda and vinegar, which sounds like we have some people who are very familiar with. I love baking soda. It's very cheap. It's very safe for children to use, and it makes for some very mind-blowing visual and auditory experiences because you can hear the chemical reaction taking place with that release of carbon dioxide. And there are so many different ways to do this. And I know that many children love to also experiment with color when educators, when you add that food coloring to the vinegar. You can also create this fun fizz reaction by using baking soda and lemon or lime juice. That would add an additional smell component to the experiment as well. And for something a little different, I'm not sure if anyone has tried this type of vinegar and baking soda experiment. We're going to watch a video of another option. That would be something much more adult-led.
Take an empty water bottle or soda bottle and fill it with about 1 cup of vinegar. Next, you'll want to take a balloon and carefully put in about 1/3 cup of baking soda. If you have a funnel, this step will be much easier. Once your balloon is partially filled, you want to attach the end of the balloon to the bottle. Careful not to let any baking soda drop in quite yet. Once the balloon is secure, lift it upright so all of the baking soda can fall into the vinegar. Once the chemical reaction begins, you should see your balloon start to inflate. The more baking soda and vinegar you use, the more carbon dioxide will be created and the bigger the balloon will be. For full instructions for this experiment and other easy science lessons you can do at home, you can head over to our website, WLTX.
This is a good time for me to point out too that I will send a follow-up email within the next few days that includes a lot of more detailed information about some of the activities that we covered today, along with some other resources about experimentation. So another type of transformation experimentation is color mixing and exploring color theory with children, which I know was already mentioned. So again, there are so many ways to do this. I love the example in the middle here of offering just an assortment of colored popsicle sticks and then inviting children to experiment by dipping the popsicle sticks in warm colored water. Let the Dragons Fly Family Childcare also had another fun experiment where Shannon drew a rainbow on a paper towel and then placed it in a bowl of warm water. And children got to witness the colors blend together in the water. So first she demonstrated it, and then later she had children draw their own designs on a paper towel and then do the experiment themselves. The last example I have for you before we then want to hear from all of you in the room is to investigate with the process of aeration or mixing air into some sort of substance. So for this, what you're going to do is you're going to pour equal amounts of heavy cream into 2 bowls. And then you can either use a homemade balance or scale or something store-bought that you may have. You can see here the image here on the right is of a homemade balance. You can use, it looks like they're using applesauce containers. You can also just use cups and punch holes in them, take some string, and like you can see in the image here, attach it to cups on either side and hang it on a coat hanger. And that can act as a homemade balance. And you're going to show children, look, we have the same amount of heavy whipping cream on this side and on this side. And then you're going to take one of them and you're going to whip it in a bowl, either with a mixer, or what you can do is you can put it in a sealed jar and then have children shake it, until it becomes whipped cream. And then you're going to take it out and you're going to balance it again. And you're going to show children, wow, the whipped version, the whipped cream, and the unwhipped, they have the same weight still. Now, obviously, toddlers, they're most likely just going to want to witness the transformation. They're not going to think too much about the preservation of weight taking place when we mix air into a substance. And infants, they're just going to want to most likely feel the texture of the cream, see it happen. But for our preschoolers, that's something that they can start to connect those dots. Wow, yeah, it is still the same weight, but this one looks so much different. And what did we do? We added some air into it. All right, we want to hear from you. Again, this is a time where you can certainly add in the chat or you can unmute. And this can be a time where you talk more about what are some fun ways that you've experimented maybe with color mixing or baking with children. Anything that involves some sort of process or chemical reaction or mixing of different types of materials. Stephanie says, bringing snow inside, turning water into snow on frigid days. Foam bubble snakes. Oh, when it says we make Play-Doh and baked cookies. Oh, and oatmeal cupcakes. Yum.
I don't know if it pertains, but over the week we have did experiments of things that float on water and on top of water. So one of them was like paper, and then the kids used aluminum foil to see would that float. And it turned out to be fun because it turned into like a little water thing. Like, so now the kids was like, what else floats? So now they putting different kind of toys and see what they flow. Now they just finding things, objects outside, like leaves, like, oh, I wonder if it's gonna soak or is it gonna sink? Like, so that was a fun experiment that we did over this week. Building the boats. We made boats out of aluminum foil and they were just floating around the water.
That is awesome. Thank you for sharing. So you played with, you played with states of matter. Like, we're going to take
Yes.
something solid and we're going to put it in liquid and see what happens to it. And then all the experimentation that comes with that.
Yes.
We are now going to end our time together talking about experimenting with construction play. So play with creating and building different structures. Again, this is something that you most likely have out and available. Something that you do throughout the day is offering children building materials. Let's further add a scientific component to it. So here are the learning possibilities of construction experimentation. So children learn so much about physics in particular when they are encouraged to experiment with building. So things like gravity, motion, and speed. They learn about force and pressure, distance, which includes, your height, length, width, and mass. So things like weight, size, and density. And children internalize these concepts simply from building with interesting and engaging construction materials, like those shown in the image here. We're going to have lots of examples of different construction materials that you can include in your program that you might not have necessarily thought of as building materials before. So we are going to start by hearing from Marilee again, how she supports construction play in her program.
So when I was traveling with my own children, we were in the Twin Cities, and there was a museum, place called The Works. I don't think it's still open, last time we tried, but it was basically a children's museum entirely consisting of building toys and all different types of materials kids could build with. And that really inspired me to really think about oh, there are so many different options of what kids can use. And what I love about construction play is that it's completely open-ended and the possibilities are endless. And so for that reason, I try to have always at least three distinctly different materials that the kids have access to. And whether that's outside, they might be playing with sandbox or the rocks or sticks. If it's inside, we have so many different things. And these are things so some things they always have access to. They always have the wooden unit box out and a large amount of them so that there's never an issue over, they've never had to fight over the blocks because there are enough of them for all the kids. And then we also vary which kind of things we have. So it might be tree blocks or Duplos, Bristol blocks. We have some magnetic ones that could be magnetiles, magformers. The new one we have are these Plixos, these little shapes, these little X's they can build. And then in the preschool room where we have smaller toys, we have Connects that they can build with, and these little even roads and things. There's these tiny little driven minis that have little roads they can create, the wooden train tracks they can build with. And then of course there's just free flowing things like kinetic sand and Play-Doh and several other different materials. I don't even know what they're called, but we have all different ones that we can switch it out with. Kiva blocks, tangrams, just some rocks, and we have Brio tools that they have their own little building toys, and the kids can hammer things together. They can use little tools to take apart, and there's just so many possibilities that's why I try to make sure that they have all these different opportunities. And if they have Duplos for a month and they're not playing with them, then we might switch it out, put the Magnetiles out, and just kind of keep it fresh. And one other thing I've noticed with the construction play is that kids often need to be shown the first time. How do I use this? It's there for them, but over the years, a lot of times the unit blocks weren't being used, and it's why aren't the kids building? And sometimes it's just they need someone to kind of show them just initially, and that someone might be you, or it might be a new kid who comes in. That kid comes in and is building something, and then after that, all of a sudden, all the kids are using them. And so if it doesn't seem like the kids are using them, it might be more just that you need to kind of show them. When we get out Magnetiles, what are the toddlers going to do? They just stack them flat. They get this flat tower. But then as you show the kids that they can actually stand them up, and then you can build a tower twice as high, it really is a lot more fun. And then they are able to expand from that. So it's not that you're showing them how they have to use them, it's just giving them that first step. Like if you'd never seen watercolors before and someone gives you a dried paint thing and a cup of water, you're not going to realize, oh, I have to mix this to use it. So it's just to kind of introduce it to them. Um, I really wish I had taken a video the other day. We just got out Magnetiles and so we got them out yesterday. This morning, the 3-year-old was building a little rocket to put his car in. So he told, there's another one who just turned 3. I was going to say a 2-year-old, but he just turned 3. And so he was trying to play, and the other one was like, so one's 3.5, one's just fresh 3. And he's like, I'm going to show him how to make a rocket. And then he was telling him, you got to put this here and this here. Good job, you're doing it. Keep trying. And it was just so sweet. And that he took it on himself, that he recognized, like, I'm the teacher. I'm gonna help him. And then just his words of encouragement were just so priceless.
Another great example of the power of mixed age play in family child care. So we're going to expand on what Marilee spoke about in terms of materials to have out for construction play. Again, I'm going to say it one more time today. Refer to the handout for a full list of material ideas to promote that child-led experimentation with construction. And then if you have more ideas, things that you have used, please add those in the chat. So thinking about mixing up the building supplies that you have out to engage children. So like Marilee said, it's incorporating things that you wouldn't necessarily initially tag as being building supplies. So this includes all of those empty boxes from food or deliveries that you get, paper tubes, cut up pool noodles or popsicle sticks even. Here we have a program using cans of food and sponges as building materials. In the center, you can see an example of materials with different opacities, and that way they reflect in different colors and they reflect light in different ways. So all of these materials are going to help promote deeper play and experimentation with building. You'll also find lots of opportunities just by having these out in your program to ask children those open-ended questions that support critical thinking that we talked about earlier. So if you have a child come and say to you, I want to build a castle, simply saying, how are you going to build it? And if they say that classic, like, I don't know, you build it. Inquiring more, well, how could we build it? Could we use this, ... and go on from there. So moving into activity suggestions. For construction experiments, we first have constructing a dam. So for this, you will need to create or have access to some sort of stream. So if you don't have access to a river or a stream like most people, you can make this using aluminum foil and cardboard, as you can see on the slide here, or just by molding a riverbed in the sensory bin, and then like with sand, and then placing tinfoil on top of that. And then just giving children lots of options to dam up the river and saying, we need to stop the water from running out the end. How could we do that? So offering things like rocks, sticks, acorns, Legos, you can see over on the left-hand side. And then you can also pair this with a literacy component, pair it with the children's book, say like, it's called Let's Build a Dam by Daniel Fair, which is also available in Spanish. And children, when they are doing this type of activity, they're learning about force and pressure and all of the components that go into how am I going to build this? How am I going to solve this problem by building a dam to stop the water from flowing? Another activity idea is similar to constructing a dam, is to invite children to build bridges. So this could be across a table, it could be across a rug. Maybe you make a little map for children, or maybe you could pair this with constructing a dam and have children then construct a bridge over the dam. And you can see some examples here of materials to use, but any building materials, just about any building materials will work for this. And again, children, when they are engaged in solving this problem, they're thinking about distance and force, when they figure out how am I going to effectively build a bridge. Now, this and the dam activity are obviously they're more appropriate for preschoolers, although your infants and toddlers are going to want to explore the materials and join in just the same. Your questions for them will definitely be slightly altered. So finally, to help children play with gravity and motion, other learning possibilities that we talked about earlier, offering different types of materials to use as ramps in their creations. Or you can do this as an experiment as a group together. So here you can see educators have used sandpaper, aluminum foil. You can see here the rug gripping material that you put under rugs or carpet, to test out different vehicle speeds. On the left, you can see this is an educator that froze just a little bit of water in a cup with a straw, and then had children make a little flag for their boat, for their homemade boat. And then they took a pool noodle, and they cut it in half, and they're inviting the children to experiment with incline. So just a fun multi-step experiment. What happens when you hold the ramp up a little higher? What happens when you push the vehicle down this ramp opposed to the one with sandpaper? And all of the scientific questions that come up and the observations that come up through all of these little simple ways that you can incorporate differences in resistance and friction into construction play. Another plug, if you are participating in Satellite, we have a lot of curriculum units and equipment that is focused around construction play and building. So I have 4 examples that I'm going to show you tonight. So the first one is the Build a Village unit. This one includes things like bamboo logs and different types of blocks that have shapes that you don't find in many classic unit block packages, we'll say. Have some linking logs, and then those little bricks that you see on the right-hand side of the image, you can see those are actually like heavy brick material. So this would definitely be something I would recommend for a preschool age child, if we are incorporating those bricks. We also have an engineering unit that includes a lot of different gears and different pieces that fit together and can be constructed in lots of different ways, including mirror blocks as well in that unit. We also have a couple of different ramp units. Now, again, this is for programs if you are participating in Satellite. This is a if you're a family child care program participating in Satellite, this is a support available to you. So for the ramp unit, we have one. The one shown here is for preschoolers. We also have one for toddlers as well. And then I also included the transportation unit to help with, again, that play with gravity and motion that can happen when we support children in play with construction. All right, now we want to hear from you again. How do you encourage construction play in your program?
I have a bunch of wooden pieces that I cast and sanded to put in different sizes and shapes. And we just have boxes and boxes that the kid can, take it and use it whatever they want. Also, we have long pieces of wood so they can mix sizes, shapes, and for them it's like they can build a spaceship, they can build a rocket ship, they can build a castle, whatever they want. It's just amazing, you know. And also we tended to take pictures and videos of those experiments or those constructions. And sometimes you think that they're working on something, but behind their own ideas is totally different. You know, as an adult, you can interpret, oh, this is like a castle. And it's not, it's something totally different. We have many, many different answers of each kid, and it's just impressive. But the wooden pieces help a lot because they can build whatever they want. And this is what we use mostly.
Yeah, and I realized, Walker, I should have included images of more like those like not life size, but that's not the word for it, larger blocks, like that take more of the gross motor skills for children to construct with. And I know that you use a lot of those in your program. Is that right?
Yeah, but we use like a very light wood. It's not heavy.
Hmm.
And I also, my father-in-law helped me sanding and cutting those pieces carefully to the kids can manipulate because we have like a 3, 4 year old. They're not strong enough, but I mean those pieces are not heavy. You can carry 5 or 6 in one hand, so it's for them easy.
Right, right. I guess not heavy, but
Mhm.
they're like bulky. That's kind of the word I was
Yes,
looking for. Yeah,
yeah,
like
and also
large.
help with the sensory thing because they can touch different like I mean feel how that wood is. You know?
Yeah, I get the texture of the wood.
Yes.
Thank you. Nicole says STEM kits are awesome for school agers. Nicole, do you have any recommendations on where to get STEM kits? Or specific ones that have been successful for you? I know you also said they're perfect for problem solving, critical thinking, and time fillers. So Nicole says she orders hers online. And Mary says the kids at my program use wood blocks and racetracks and cars they like to build and play with. Social says block play, architecture books that are age appropriate. Oh, and what a fun idea that we didn't recognize the cave and fort building. So using blankets, scarves, belts, clothespins, boxes, etc. That is all of our content for tonight. I want to thank you so very much for coming tonight and participating and talking about science and how this can be incorporated more intentionally in early learning programs.